Hi, my name is Elizabeth, and today we're going to be going over lipids. So we're going to go over the monomer, the bond type, the components, examples, and the functions of them. So let's go ahead and get started, right? So everything has a monomer. Lipids are macromolecules. Macro means big. Everything big is made out of something small. So the monomer, or the small component of a lipid, is called a fatty acid. Well, these look kind of like the same color. So fatty acids are the monomers, and those fatty acids are going to be connected to each other by ester linkages. Specifically, when you're making a triglyceride, and we'll talk about what that is. This is where the ester linkages really come in. Fatty acids, since they're just carbon and hydrogen, right? Those are the components of them. They're actually just connected by covalent bonds. But when you're trying to connect a fatty acid chain to something else like a glycerol, you're actually going to form an ester linkage there. So that's where that comes in. All right, so the components are just carbon and hydrogen, but you can have two different kinds of lipids. So you can have something called a saturated fatty acid and an unsaturated fatty acid. So I'm going to use pretty relevant examples as to what these are. So a saturated fatty acid will be a solid at room temperature. Think of butter. Butter would be a saturated fatty acid. What that means is that every carbon has the maximum amount of hydrogen surrounding it. So if I have a carbon chain, kind of like this, everything will have the maximum amount of hydrogens around it. Right? And notice there are no double bonds in between my carbon chain. It's all single bonds. So in a saturated fatty acid, there are only single bonds, S and S. Right? The reason why these form solids at room temperature is because they're just linear. There's really no branching. There's no weird shape going on. They're basically just forming sheets of carbons. So they easily stack up on top of each other. There's no space in between them. So when they are just packed up on top of each other, they form a solid. The difference between a saturated and unsaturated fatty acid is that these are going to have double bonds, etc., etc., which changes things. Because remember, carbon can only form 4 bonds. So here it has 1, 2, 3, 4. Here it already has 2. So that means it's only going to have 2 hydrogens instead of those 3 around it. Here this one has 1, 2, 3, so it's only going to have 1 hydrogen. This one also will only have 1 hydrogen, and this one's going to have 2. So as you can see, it doesn't have as many hydrogens. It's not as saturated with hydrogen, so it's unsaturated, right? Now, what happens here in like a linear form, each of these double bonds is going to create kind of a kink. So here, linear or in a line, right? These just form sheets like this, the saturated ones. The unsaturated ones are going to have these kinks, right? And they're all going to be kind of different, or at least in different orientations. So this one might be like this instead, and then the other one might be kind of like that. So if I try to compress these together, they're not going to form as a condensed sheet as the saturated fatty acid will. So these are going to be more fluid in nature at room temperature. Think of olive oil or any other oil that you can think of that's not going to be solid at room temperature. Right, so that's the difference between a saturated fatty acid and an unsaturated fatty acid. Notice that unsaturated fatty acids have these double bonds here, and they'll have them spaced out throughout the entire chain. Right, these are very small. Lipids are actually very long. So let's go over some examples. We have our triglycerides. Right? So triglycerides, what they're made out of is that they have a glycerol and 3 fatty acid chains. All right, so they look kind of like they have their glycerol here. This is their glycerol head. and then they have 3 fatty acid chains. They look kind of like jellyfish, but you know. Right? And then you have phospholipids. Phospholipids are my favorite kind of lipids because they do just so much, you know. So glycerols, their function is basically just to store energy. So if I need some of these fatty acids, I can just kind of pop them off and replenish them later when I need to, right? Phospholipids, though, they're real MVPs, all right? They make up our cell walls and our cell membranes and stuff like that. Without them, we don't have cells, and that's magical, all right? So a phospholipid will have a phosphohead, or a phospholipid head, or a phosphate head, and then they'll also have 2 fatty acids. Specifically, it's going to have 1 saturated tail fatty acid and an unsaturated fatty acid. The reason for that is because at different temperatures, they work differently, right? So a phospholipid looks kind of like this. This is the phosphohead, and then it's going to have the saturated fatty acid, and then it's going to have the unsaturated fatty acid, right? These form membranes. This here, the head is hydrophilic, which means it loves water. Fats, though, these 2 guys here, are hydrophobic, which means they hate water, right? Phobias, phobic, they don't like it. So what's going to happen is that they're going to form these membranes. And I'm just going to draw it kind of over here, right? So all these little heads are going to be where the water is. And they're going to form kind of like a barrier. And then the tails are going to be this way. Right? So the tails, since they're hydrophobic, they can interact with each other instead of having to interact with the water. This is called a phospholipid bilayer. And this is what makes up the membrane of anything that has a membrane. So like our cell walls, anything within our vacuoles will kind of have these 2, or lysosomes and stuff like that. Everything, well, you'll learn about that. But everything kind of has this phospholipid bilayer, right? And then you also have steroids. They're also lipids. And steroids, you can definitely tell what they are because they're kind of just like a bunch of hexagons or pentagons put together, right? So I'm just going to make one up. I don't know if this actually exists, but they're going to look kind of like this. And then they'll have functional groups on the sides. So your functional groups can be anything from like an OH to a methane, which is CH3, etc., etc. And these are important in your cell membrane because they resist temperature changes, and they also act as signaling molecules. So steroids are the framework for things like estrogen and testosterone and all of that. So the reason why our body works the way that they do is basically because steroids can go in and out of cells because of their lipid structure. So let's go ahead and do a little recap. So the monomer for lipids is a fatty acid. The bond type in between the fatty acid and the glycerol is going to be an ester linkage. In between fatty acids, though, they're just going to be covalent bonds. So these here are covalent bonds. The components are just hydrogen and carbon, unlike carbohydrates, which have oxygen. We have the examples that we went over. So we have triglycerides, which is just a glycerol and 3 fatty acids. Our phospholipids, which are my favorite, with a hydrophilic head and the 2 fatty acids. And our steroids, so the precursors for estrogen and testosterone. Right, so and we kind of went over the functions. So the triglycerides act as a storage. Then we have our phosphoheads, right, or our phospholipids, my bad. Lipids. That says phospholipids, okay. I know it doesn't, but it does. They do the bilayer stuff, which is this stuff. And then we also have our steroids. And their function is to send messages. So they signal and they help with membrane fluidity. All right, and that's the basics of lipids.